Okay, so we are continuing our chapter 4, transformations, and today we're going to be looking at rotations and congruence transformations. So, to start off, there are certain rules for a rotation. So please note, a transformation in which a figure is turned about a fixed point is called the center of rotation. It is a rigid motion, and rays drawn from the center of the rotation to a point and its image from the angle of rotation. So here is the point. So here's the figure that we're looking at, and if we rotate that thing this way, that would be a 40-degree angle of rotation. So here are the coordinate rules as long as you are rotating about the origin. Okay, so we will rotate around other points, but as long as you're rotating about the origin, it's just set. So if you've got point AB and you rotate 90 degrees counterclockwise, CCW is counterclockwise, then they trade places and the B is opposite. If you rotate 180 degrees counterclockwise, they stay in the same position from AB, but they both become opposite. If you rotate 270, they switch places and the A becomes opposite. And if you rotate 360, you're back where you started, so you're back at AB. And remember, your A and your B is in the place of XY. All right, so we're going to graph the image. We're going to graph the image of the polygon after a rotation of the given number of degrees. So they want me to rotate this 180 degrees. Well, to rotate 180 degrees, the rule says that to go from XY, and we're going to rotate 180 degrees, is they stay in their position, X and Y stays in their position, but they both become opposite. So if you identify the points of your pre-image, so here's point J, which is -1, 2, 4. So this is 2, so -2, 4. So -2, 4. K is, well, this is -4, and that's halfway, so that would be -5, 1. So -5, 1. L is -2, -2. And M is at 1, 1. So now, if I'm going to rotate this thing 180 degrees, then the rule is that they stay in their same place. So they're not going to switch places, they're going to stay XY, but, well, that didn't do any good there because I switched the color. But they're both going to just change signs, so they're just going to become the opposite of what they were. Okay, I need this to write thinner. Okay, so they're both just going to, so if they stay in their same location, so this -2 is going to be +2, and the 4 is going to be -4. So we're going to rotate it around. All right, so this is going to be 5, -1, and this is going to be 2, 2, and this is going to be -1, -1. Why won't this thing change colors? All right, so now plot your new points so we can see what it looks like when you rotate it 180 degrees. So now I'm going to go 2, -4, 2, 4, 5, -1, 2, 2, and -1, -1. And then when you connect it, so let me get a line in here. So our 2, 2, so this was L, this was the negative, this was 5, -1, this is K, so KL, 2, -4, so this was J, so JKL, and this is your point M. So notice it's still the same size. It did not change size. All you did was you took this and you rotated it 180 degrees. And you followed this rule. All right, let's try another one. 270, so let's get our points. So our pre-image is, let's see, A is, so these are counting by twos again, 2, 4, so that's going to be 1, 4. So 1, 4, 4, 3, 3, 1, and 1, 2. So 270 rule is XY, and the rule is for 270 that they trade places, and the first one changes signs. So they're going to trade places. So my Y is going to become my X, and my X is going to become opposite, so 4, -1. So basically these numbers over here are all going to be first now, 3, 1, and 2. And then these numbers are going to be opposites. So -4, -3, and -1. And there are your new points. So when we plot them, we go 4, -1, so there's A prime. 3, -4, there's B prime. 1, -3, there's C prime. And 2, -1, is D prime. And when we connect them, it should give us the exact same figure. Of course, it's going to look a little off, but that's rotating it 270 degrees. So you went from here to 90 to 180 to 270. All right, here we go. Now we're just going to rotate 90 degrees. The rule for rotating 90 degrees is very similar. I guess it would help if I had the actual pen out. So the rule for rotating 90 degrees is they're going to switch places, and the Y becomes negative. So let's find our RST. So R is at 40. S is at negative, oops, that's -40. -1, 5. S. So make sure I got that right. That's 2, that's 1, 5, okay. And T is at, it looks like 2, 4, -5, 1. So -5, 1. All right. So now they're going to trade places. So let's go through and notice that the X becomes the Y. So I'm just going to replace all those X values over here. And now the Y's become your X's. So 0 is still 0. 5 becomes a -5. And 1 becomes -1. So there is your new points. So if we plot these, so we go 0, -4. So there's R prime. -5, 2, 4, 5, -1. There is S prime. And -1, -5, which is about right there, is your T prime. And then connect your dots. And there is the rotation of that triangle, 90 degrees. And I will also show you in class a way that we can do this when you're rotating your paper, so you can visually see it. All right, so this time it's called a composition transformation, which means you're going to transform more than just one thing. Like we did translations, then we just did reflections, and now we just learned rotations. So what happens if I want you to do two things? What if I want you to reflect? Then I want you to turn it. So flip over the x-axis, then rotate. So first thing you have to do is you're going to have to reflect first. And we're reflecting over the x-axis. So what you have to do is you have to find all your pre-image. So we're doing these simple with just 2 points instead of a whole figure. So we're just going to do a line segment. So what we need is M and N, and then we need the reflection, which is M prime, and then the rotation, which is M double prime. So point M is located at, make sure this is still skinny, -4, 4. So M is at -4, 4. And N is at -1, -1. All right, so a reflection over the x-axis. Remember, the reflection over the x stays the same, y changes. So my M prime, N prime. So just the reflection, x stays the same. So my x stays the same in both. And the y is opposite. So that's going to be -4, +1. So now if I did -4, -4, -1, +1. So that is N prime, that's M prime. So that is a reflection. And then to rotate 180 degrees, from here, you have M double prime, N double prime. So to rotate 180 degrees, they just change signs. So now these are just going to change signs. So -4, -4 becomes 4, 4. That's going to become +1, -1. So first I rotated, first I reflected over the x-axis, and then I turned 180 degrees. So 4, 4, so there's my M double prime, and 1, -1, there's my N double prime. So there is my new line. So you have to do two things. You have to do two rules. So we're going to rotate. So we're going to rotate 100 or 90 degrees. So to rotate 90 degrees is -yx. And then we're going to translate. So I'm going to rotate it, and then I'm going to slide it over. So the first thing I'm going to do is let's find our points M and N. So M is at -2, -1. N is at 3, 1. And then M prime and N prime. So M prime, they switch places and change signs here. So the x becomes my y value. So the x becomes my y value, and the y value changes signs. So +1, -1. So now I've got +1, -2. So there's my M prime. And then I have -1, 3. So there's my N prime. So there is a rotation of 90 degrees. So we just rotated it, went 90 degrees. Now M double prime and N double prime is our ending result. So they want me to add 2 to the x's. So 1 plus 2 is 3. -1 plus 2 is 1. And then they want me to subtract 3 from the y's. -2 minus 3. 3 minus 3. And now here's my ending results. So let me do that in a different color. All right, so 3, -5. So 3, 2, 4, 5. And then 1, 0. 1, 0. So there's my M double prime, there's my N double prime, and there's my ending line. So I just took this here and I just slid it over and down. All right, last one. So the rotation of 270 degrees. So remember, it's going to be y, comma, -x, and then reflect. So if we reflect over the line y equals x, we're going to reflect over that slanted parent function, Remember, the points just trade places. So they just trade places. So let's find point M and N, and then we'll do our calculations. So M is at 3, 4. N is at 3, 1. All right, so first thing we want to do is rotate. So to find our M prime, N prime, the Y value becomes our X, so 4, 1. So 4 and 1 are our Y values that become our X values. And the X value changes sign, so that's -3, -3. All right, and then they want me to reflect over the parent. So now if I reflect over the parent function, y equals x, m double prime, n double prime. And they just trade places. So this becomes -3, 4, no fancy sign change or anything like that. And that becomes -3, 1. All right, so let's graph these. So 4, 3. So 4, -3 is my m prime. And 1, -3 is my n prime. So that is a rotation of 270 degrees, so 90, 180, 270. And then we're going to flip over the parent function. So -3, 4. So there's m double prime. So from here, it goes up to here. And -3, 1. So there's n double prime. And there's your reflection. So you reflect it over this line that goes through here, that way. All right. Now we're going to graph the triangle JKL with vertices J at here, K here, and L here, and its image after the composition. So let's graph these 3 points here. So I'm just going to count these as 1s instead of 2s. So this is 1, 2, 1, 2, 3. So there's point J. K is -1, 1. And L is -1, 0. Did I get this? -1, 1. This is a funky looking triangle. 2, 3, -1, 0, and -1, 1. I think this should be +1, -1. So let's flip that. So +1, -1. So here is my K. So let's erase that. I like this way better. And this is L. Otherwise, we have this really, really strange triangle. All right, so now let's draw it. So there's JK, KJ, JL. All right, now we are going to rotate 180 degrees. To rotate 180 degrees, it's -x, -y. So all of these points are just going to become opposites. And then we're going to reflect over this line, x equals 2. So let's do J prime, L prime, K prime. And I wrote those out of order. Let me get those in order where it makes a little bit more sense. All right, J, K prime, L prime. All right, so just change the signs. So this is -2, -3. This is going to be -1, +1, and this is going to be +1, 0. So now here are our new points. So our new points are -2, 1, 2, 1, 2, 3. So there's J prime. Sorry, that's 1 prime. -1, 1, JK. And 1, 0, there's L. And now I'm going to connect those. Trying to keep them color coded nicely where it makes visual sense. And then the last thing we're going to do is reflect over this line. So the line we're going to reflect over is x equals 2. So if I go to 2 and I draw a line through it, we're going to reflect the red triangle over that point. Well, to reflect over that point is, let's see, where is mine? All right, so remember the whole rule is to stay the same distance away. So if I'm one distance away here, I need to be one distance away here. So let me see if I can get this to scoot over just a smidge where it's more evenly. All right, there we go. Okay, so reflecting is maintaining distance. So J double prime, K double prime, L double prime. So point J is down here. So I'm 1, 2, 3, 4 units away. So I need to be 1, 2, 3, 4 units away. So I'm going to be out here. Well, this is at 2, 3, 4, 5, 6. So my x value is 6. So I'm out here. The y value is going to stay the same though, so it's still going to be -3. My k value, so if I'm here and I'm 1, 2, 3, 1, 2, 3, so k is going to be like right here, 2, 3, so this is 2, 3, 4, 5, so 5, and k will stay, the y value will stay because we're flipping horizontally, or over a vertical line, sorry. And then L, which is right here, is 1 unit away, so L will be right here. So if it's 2, that's 3, and then 0. So that is where we are going to wind up. So let me connect all of these dots. We'll do this with the green. All right, so here is, oops, that's not what I wanted. All right, we're just gonna have to make do. All right, so I rotated it 180 degrees and then I flipped it over the line, and this is where we wound up. Okay, now next one is the same triangle. So